We talked about MapReduce earlier, so now let's move on to Spark. Spark is another programming model for semi-structured data. Why do we need another model? As we saw earlier, MapReduce has its own rough edges. For instance, everything must be expressed using mappers and reducers. And also, because it writes all intermediates to the disk for fault tolerance, running MapReduce jobs can take a long time due to waiting for the writes to finish. Spark was developed right here in Berkeley with goals to address these issues. Unlike MapReduce, it is also a programming model over the Hadoop file system. In contrast, however, Spark programs are not confined to mapper and reducers, but rather they are called steps. You can think of a step as an operator similar to a relational algebra operator that writes out the results in memory. We will see in a second what that means. Spark has multiple language bindings. In this class, we will give examples using its Java interface. As a side note, recently, they have added a SQL interface as well as the existing language bindings that, in this case, compiles SQL queries into the Java native interface. Like MapReduce, Spark also uses a semi-structured data model. Unlike MapReduce, however, these objects, which can be anything from key-value pairs to just objects of a certain type, are organized into RDDs, or resilient distributed datasets. You can think of each RDD as an immutable dataset that cannot be changed once created. Each RDD can be distributed across multiple machines, and it also remembers its lineage. A lineage is an expression that states how the RDD itself was computed. You can think of it as a relational algebra plan, for example. Why do we keep track of each RDD's lineage? Well, while all intermediate results in Spark are also stored in memory as RDDs, they will be lost if the server crashes. But since we know how each RDD was computed, we can recompute the RDD from its lineage rather than starting the entire program from scratch. This means that we must have stored the lineage in persistence storage, like writing it out to the disk before executing the program that generates the output RDD. In practice, this can be done by writing to a log file and flushing the log to the disk, just like what we learned earlier in the recovery lecture. Now, unlike MapReduce that consists of mappers and reducers, each program in Spark consists of operators. And operators are categorized into transformations and actions. Actions are eager operators that are executed immediately when called. Transformations, on the other hand, are lazy and they are not executed immediately. What does that mean? That means we just record it in the lineage log and we don't actually carry out the function just yet. Why do we do this? Well, one of the benefits is that we can group together multiple operators and fuse them together. For instance, if we have two consecutive selections, one after another, then we can combine them together as a single selection so that we don't need to iterate through the entire RDD multiple times and save some IOs.